The next section we will learn is called point-slope form. So up until this point, we did what's called slope-intercept form. And we know that that is y equals mx plus b. The useful part to this is that it gives us our slope and it gives us our y-intercept. Point-slope form, as you can tell from the name, is useful when they give us a point, an ordered pair, an x and a y, and the slope. So notice there's not a y-intercept here necessarily, but there is a point, and then we'll still have our m. The point-slope form of an equation is y minus y1 equals m parenthesis x minus x1. That is something you have to have memorized, something we'll use a lot. Similarly, like you memorized y equals mx plus b for slope-intercept form. Now, what do all these things mean? Where x1 and y1 are the coordinate pair numbers. So the points you're given, you will plug in for x1 and for y1. M is the slope, there's nothing new there. The regular y and the regular x, you are not touching. And when I say regular, I mean the y and the x without a 1 next to it. You will just rewrite that as y and x. Notice your negatives. So if your ordered pair has a negative in it, you will have a double negative in the formula, which will turn it to a plus. Let's see what this looks like. A line passes through the point 8, negative 4, and has a slope of negative 5. What is an equation in point-slope form of the line? Read carefully, point-slope form. So I know my point-slope formula. I'm going to rewrite it. And I'm going to plug in the information I have. So my regular y, I am just rewriting as regular y. My y1 in my ordered pair is negative 4. So I have y minus a negative 4. We know two negatives make a positive, so I'm going to change that to a positive right away. Equals my m, which is my slope, which the problem says is negative 5. My regular x, I am leaving as regular x, minus my x1, which is 8. That is my answer. I just wrote that information in point-slope form. Notice, different than slope-intercept form. Slope-intercept form, y is alone. Point-slope form, y is not alone. Okay, so that's the difference there. We can be asked to graph in point-slope form. So the hardest part about this is picking out your points from your equation just because of the signs. So it says, what is the graph of the equation? And there it is. The slope should stick out at us, right? The slope is the number before the parentheses, or m. So in this case, our slope is negative 4/5. Now our point here. Remember when we plug in our points to the equation, the sign kind of changes, right? Like here, our x was a positive 8. And when we plugged it in, it turned to a -8. Here, when our y was a -4, when we plugged it in, it turned to a +4. So when we pull the points out, we are going to switch the sign as well. So our ordered pair here, our x value would be +4. And our y value would be -3. That's the hard part, just remembering to switch the signs. To graph this, first we're going to graph, or plot, I guess I should say, the point. Then do your rise over your run, and then connect them. So remember, in slope-intercept form, we plotted the y-intercept first, and then we did the slope. So here we're graphing our point first. So 4, -3, I'm starting at the origin, I'm going over 4 and down 3. And then for my slope, it's -4 over +5. But if you notice on my graph, I would run out of room as soon as I started to go right 5. So what can I do? I can flip the way I say this and give the negative to the 5. So I can go up 4, 1, 2, 3, 4, and left 5, 1, 2, 3, 4. Like that. Rise over run, remember. Go up or down first. And I'm going to fill out my graph when we go up 4 again. 1, 2, 3, 4, 1, 2, 3, 4. And then I'm going to use a ruler and get a straight line. That is how you graph in point slope form. Okay, similarly here, find your slope, pull out your points. So if you want to pause the video and try that yourself. So my slope is 2/3. My point is +2, +1, because I switched the signs. To fill out my graph, I'm also going to go down 2 and left 3. Right there. And connect them. And that is my graph for that equation. Similarly to slope-intercept form, we can be given 2 points and asked to write it in point-slope form. So for point-slope form, recall, we need a point and we need the slope. So if I give you 2 points like this, I don't know the slope right now, but I know how to find the slope from 2 points from last section. My slope formula, if you recall, is y2 minus y1 over x2 minus x1. So now I'm just going to plug in my y's. -3 minus 4 over -2 minus 1. I'm just careful with my signs. And I get -7 over -3, which I know I have to change. Negative divided by negative turns to a positive. So my slope is 7/3. So I have my slope for point slope form. Now my point. Notice I have 2 points. I have -2, -3, and I have 1, 4. You can choose either point. Just like when we found the b in slope-intercept form, and I said choose either point, it doesn't matter. Same thing here. You pick whichever point you want to pick. And that's what you're going to plug in to our point slope equation. So I said here I'm going to pick the first point just because. So ready? Y minus my y1 from my first point is -3. So since I have two negatives there, I'm going to change that to a positive right away. Equals my slope, which I found above, is 7/3. Parentheses. I'm not touching my regular x. And my x1 from my point is a -2. So minus a -2, I turn it to a positive. That is my answer. If you would have picked the other point, the 1 and the 4, your equation would have been y minus 4 equals 7/3 x minus 1. While they look different, if we would solve this all of the way, which we'll do next, it would give you the same answer. So either one of these is correct for that problem. Going back and forth between slope-intercept form and point-slope form is super important, and it's not hard to do either. If you remember how to distribute, which you should, it is not hard to do. So what we're going to do is we're going to go from point-slope form, and we're going to convert it to slope-intercept form. I'm going to use the problem we just did. So on the left, I said y plus 3 equals 7/3 x plus 2. Notice we need y alone. So the first thing I'm going to do is I'm going to distribute the right-hand side. So I'm going to bring down y plus 3, and I'm going to distribute. I'm going to do 7/3 times x, which is 7/3 x. And I'm going to do 7/3 times 2, which is 14/3. Y is still not alone. I'm going to subtract 3 on both sides. Y equals 7/3 x. Notice I gave the 3 to the 14/3 and not the x term because they're not like terms. And then I'm going to do 14/3 minus 3, and I get a positive 5/3. That is in slope-intercept form. Notice y equals mx plus b. My m, of course, will be the same as up here, right? My m up here was 7/3. My m down here is 7/3. And then my b is 5/3. If we solved the right-hand side up here, if we distributed that and then added 4, you would get the same answer as down here. How would you like to graph this, though? How would you like to graph a b of 5/3? That's 1.66. Repeating. That's hard to graph, right? Graphing the point up here would be way easier. So pros and cons of both methods. Okay, here you're given a graph, and it says write an equation of the line below in point-slope form, and then write the equation in slope-intercept form. Slope-intercept form, the second one, we know how to do that already. We need a b, and we need an m, right? So my b is where it crosses the y-axis, which looks like is 2. And then you just want to pick another clean point, which looks like that right there, and do your rise over your run. Looks like down 1, right 2. And we can plug that into y equals mx plus b and say y equals negative 1/2 x plus 2. For point slope form, we just need a point and we need a slope. We already know the slope because we just found it on the right. And then a point, you can pick any point on that graph. Any point you want that has a clean intersection point. I'm just going to pick that point. That point is what? 2, 1. So I have a point and I have a slope. I'm now going to plug it into my point slope formula. Y minus y1 equals my m x minus x1. And those are my answers. Those are my equations in point slope and slope intercept.